Okay, so this is the generative system that I've created in Max MSP, and basically it makes use of a range of different algorithmic processes which have been combined with each process controlling different parameters. So first process used is based on an L system, which is an iterative process and works using fractals. The L system has an axiom of notes which predefines what notes are going to be played out of the system. So the user can predefine these 4 notes, and the L system will create a set of production rules for each note. So if we do one iteration, so basically what will happen is the C will be played into the system and it will output 4 notes. Another C will be played and it will output 4 notes. A will be played and it will output those notes, and E will be played and it will output those notes. Now, more than one iteration can occur whereby this sequence is then looped back into the L system to create 4 notes for each of these notes. So you can see that happening there. So yeah, this has created 64 notes from 16 notes. Okay, so that is the first process. The second process is kind of buried within the system, and it features a process which is a first order Markov chain. And what it does is it analyzes this sequence data and creates a table of probabilities of a first order. So it looks back at the last note and the current note. And what it does is, based on the last note and the current note, it creates a new note, which is then played simultaneously with the first sequence. So 2 sequences in actual fact are actually playing now. And then there's a third sequence which is introduced following a Morse-through sequence process. What this does is takes the incoming data from the first sequence, converts it all to binary, and then adds the binary numbers within each term. So for instance, if the number 4 was to be converted, the binary would be 101, and so the Morse-through sequence would create 2, as there are 2 ones in the term. This is then used to create an additional note sequence, which is this third sequence here. So to play these 3 note sequences, 2 different types of synthesis have been used. This is additional or additive synthesis, and frequency modulation, which is right now. So each of these partials are kind of subpatches within Max MSP, which holds a cycle object, which is basically an oscillator. So the first sequence that we talked about from the L system is played back by the first 6 partials, and then the sequence created by the Markov chain is played back by the next 6 partials. These are then eventually added together to create a single signal. 2 amplitude envelopes have been used for each of the 6 partials, which determine the characteristics of the sound in terms of its timbre and dynamics. So this signal is then multiplied to a simple oscillator, which is used to play the sequence that comes from the Morse-through process. and as you can see there is a volume control, and then this goes to the main output. So the last process that's used in the system is this game of life system, based on John Conway's cellular automata. And what it does is it analyses a grid of cells which are predetermined whether they are alive or dead. It uses a set of rules to determine the next state of the cell. So basically what it will do is create lots of different variations based on a few sets of rules. Now this grid is actually used to control 3 different parameters in the composition. The first parameter is the y-axis cell additions, so this adds up all the cells in each column, and it looks to see how many cells are alive. The amount of cells that are alive is then output to control, is used to control the phasing relationships of each of the partials. The x-axis cell additions can relate to how many cells are alive in each row, and these are used to control the partial frequencies of each of these oscillators. And what the partials are multiples of the fundamental frequency. There's also been an object implemented to scale the range of partials, so we can determine a range of partials between so many. So the higher the number, the higher pitch sounds that are going to be produced. And then finally, a cell addition process is used to find the total amount of cells alive in the grid, and this is used to control the tempo of the entire system. And so basically what happens is the less cells that are on the grid alive, the slower the tempo, and the faster, obviously. This has also been broken down into 4 different settings which have been scaled dependent on the amount of cells that are alive. So for instance, we have a slow which controls a range between 10 and 30 BPM, medium 30 and 60, and so on, and then the variety at the end, which is between 10 and 90 BPM. So I'll play the system back now with one of the defined presets. Oh, volume, sorry. And actually these notes can be programmed to whatever. So let's set that again. I can change the partial a little bit. We can constantly modulate which cells are alive in the grid, and every time we click on the grid it will reset the Conway game of life process. And so there we have it. Thank you for watching.